Hello dear students, it's your instructor Muhammad Ali Musawir from UET. Today's topic is eye diagram. In analog and digital communication lab, we will study eye diagram. So what is this actually? In the digital communication, eye diagram is used to determine the quality of the received signal. We can analyze the diagram, we can analyze the graph, and then we can check the quality of the received signal. So what we do actually here, we use an oscilloscope, actually a digital stored oscilloscope, and we can connect the receiver to the oscilloscope, or if we want to analyze this in the laptop, we can use MATLAB for this, and we will see a graph like this. And why it is called an eye diagram? Because the structure is just like an human eye. Alright. So we have different things that tell us the quality of the signal. We have the eye height, width, bitrate, rise time, fall time, etc., etc. That tells us the quality of the received signal. Let me show you the points here. Parts of the eye diagram. Sometimes the eye is closed and sometimes it is open. In the previous diagram, you can see that it looks like an open eye, so it is known as the open eye. So if we talk about the vertical opening of the eye, so larger the opening means the better signal we have, means the better quality we have. If we talk about the eye height, the distance between the top and bottom of the eye, alright, this is the eye height. If we talk about the eye height, it indicates the signal to noise ratio or margin. If we talk about the eye width, so narrow width indicates timing, jitter, or synchronization problems. Crossing points, you can say these are the crossing points we have. Ideally, the crossing points of rising and falling edge should be at the center. Means these points should be at the center. From where? From this, you can say the reference and this reference, this point should be at the center. Okay. Decision instant, the optimal sampling point usually at the center of the opening point. Alright, so we have different things that tells us the quality of the received signal. Okay, now let's analyze some graphs so that we can understand what actually it looks like on an oscilloscope. This is the ideal eye diagram. When we have a pure, clean, clear signal, our eye diagram will look like this. These are the crossing overs. Okay, so the pure, or I can say the clean signal, it will look like this. If we add some noise to it, it will look like this. You can say that here we have some distortion, some noise, okay, and here we have the crossovers. If we have some noise and jitter, it will look like this, where we have some very, you can say, high vibration fluctuations. Alright, but here, till here, we are still able to understand that the signal is receiving, and somehow we can say that we have 1 or 0, because you know that, as I said earlier in the starting, that it is applicable on a digital signal, means where we have 0 and 1. Okay, so we can still identify the signals. Now I can say that till here our eye is opened, but now here if we have very high noise, if we have very bad signal, then the eye will be closed like this. Okay, the eye will be closed like this, and here the identification is you can say that is very tough, and we cannot identify the signal. If we talk about some points, means this was the reference line. I said this line is showing us that we have high voltage 1. This line identifies we have low voltage, means 0. So this line identifies 0 and this line 1. So a good signal will look like this, and we can identify where we have 0, where we have 1, and the crossing over, etc, etc. But here if we have a bad signal like this, we cannot identify where is 0, where is 1, where is 0, and where is the crossing over, etc. So we can here find the vertical height, width, etc, etc in a perfect signal, but here we cannot identify these. Alright, so this was the concept about the eye diagram. Now let's move towards the practical. We will do this on oscilloscope to understand it in the real life, in practical. Now let's move towards it. Alright students, so this is how our eye diagram will look like. Below one is the message signal, means the pulse signal, the 0 and 1 in the 0 and 1 form, and the upper one is the eye diagram. Okay, so how it is formed, let me tell you. First of all, let me change it. Means what I am doing here I am actually moving it, I am actually displaying it in the real form, means the thing that is received, means in the pulse form, in the 0 and 1 form. So first of all I have shifted it in the real-time signal, means the signal that is received by us, the signal in the pulse form. Now what is happening here? The pulses are actually overlapping each other. The zeros and ones are overlapping each other, and they are now actually looking like our eye diagram. That's the concept. The overlapping of these pulses are actually forming the eye diagram. Okay, now if I talk about the distortion, if we add some distortion here, our eye diagram, it will look like this. You can see that there is some distortion, the crossing overs in the reference axis. Okay, so we are still able to configure what is actually happening here. You can see that there is noise, and it is what it is actually an open eye diagram. Okay, open eye diagram. Perfect. Now let's talk about the jittering of the wave. So it will look like this one, means the distortion that we have in our signal. Okay, so it will look like this, the distortion. Okay, so after it our signal will look like this one, means some more close one, or some fluctuations. Okay, or some, you can say that oscillatory motion we have. Okay, so this was our experiment about eye diagram. Thank you for watching here.